Hi everyone, how are you doing? Thanks for coming on this last day. I'm sure you guys are exhausted. I know I am. It's been a busy couple days. It's been awesome stuff. I've got a ton of content, so I'm just going to start burning through it. So I'm Mike Wuetherick. I'm a senior producer at Made with Unity team. We work with a lot of the creators of content that you see, the Baymax Dream stuff that's been shown all over the place. And then last year we worked with Neill Blomkamp's Oats Studios on the Atom short films. So my team was responsible for sort of teaching them how to use Unity and get into the process. So we're going to go through both episodes, so 2 and 3. There's a ton of content here. Oats Studios, don't need to introduce them. Neill Blomkamp's amazing director. He's awesome, organized a really cool crew. They worked on a whole bunch of different shorts, their Volume 1 shorts, and we were very lucky to be sort of included in that. They had this amazing team of VFX artists, CG soups, real-world costume designers. Their studio was the world's largest man cave. It had robots and guns and RC cars and like a literal real helicopter inside of it. It's amazing. It was the coolest place to work. And they've obviously a lot of their Oats Volume 1 stuff is up on Steam, so you can actually get their source models to try out and play around with it. Without further ado, let's go through the episodes. So here's a little teaser.
You want to know what you are? The mirror can tell you who you once were. She knows your histories, your crimes.
So Atom was originally created by Ves and Sylvia. They're part of our Stockholm demo team. You've probably seen their content throughout Siggraph as well. The most recent thing they worked on is the Book of the Dead stuff that's been shown off. Amazingly talented team. They are sort of the other team within Unity that creates some amazing content other than the Made with Unity team, but real time. So this is the team. They, again, crazy talented group, but they had never used real-time. They'd been wanting to. They've been talking about it for 15 years internally. They actually switched to Redshift as their renderer pretty early on. So they were using GPU rendering, but they hadn't actually jumped fully into real-time. So this was when we had the opportunity to partner, they jumped on it right away, the whole team. So the Atom projects, they were built with the vanilla Unity 2017 1.1, which feels like antique technology these days, but it's so last week. The project size, roughly about 50 gigs of content in the actual Unity project. They're about 5 terabytes of source assets and so on. The executable, when we bake it down, is about 4 gigabytes. That's what we were playing at the real-time live. We use a lot of the same features with 25 to 30 different nested timelines throughout. The first thing we had to do was expand the universe. So they created the original shorts. And I'm just going to go through this quickly because there's a ton of concept art. But Neill had some amazing concept artists put together some sketches of what he wanted to put together. And as you can see from the concept art, he was able to achieve the final look really close. Everything from weapons to the characters. The Atom universe hadn't really been expanded beyond the original short. So he had this sandbox to build out. And the first thing they did was approach it just like they do all the other shorts. They started with location scouting. They wanted to do everything the way that they normally do. It just happens to be the output is done in Unity. So they found this location, this is actually the real world photos where they went down, and here's the CG version of it. So they went in and basically supplemented and kind of did the paint overs to figure out what they wanted it to look like. And then they started on costume design. Again, approaching it just like they do all their normal feature films. So the costume designer created the actual real-world costumes, and then we brought them in. So starting with environments. So photogrammetry played a huge role in this. So they went down to location, they hired a drone crew, they shot about 30,000 different photos, essentially flying the rings around the environment to sort of build out the section that they wanted. They brought all those back to the studio in Vancouver and then crunched it all in reality capture. So again, thousands and thousands of photos, this huge data set. Every point is basically all the floating ones or all the cameras that they shot. Chris said his legs were really sore afterwards from doing the crouch move. So it's kind of a combination of those. And then we brought it into Unity, and with the delighting tools and all the other sort of goodies that Unity's provided, then we have, this is the in-engine version. And when you jump into the environment, we actually did a little experiment with VR. It's startling how close it looks. And then they realized they needed some secondary props. So they called up a prop company in town here, and they just brought a dump truck full of stuff, barrels, whatever. They set up this in their back lot, and they did a secondary shoot. And this was sort of some of the props that they organized from the secondary shoot. And then in engine. They also went to a recycling depot in town here, and they needed like a pile of electronic trash. So they went out there and they're like, can we just borrow a bunch of garbage and do some photogrammetry? And they're like, you guys are weird. But sure. And they bought them like a case of beer or something, and then they did that. And then they brought it into the engine and did the scan, took a ton of photos, and then brought it in. So the Unity has a delighting tool that's available for free. This is very good for cleaning up your textures, getting rid of all the extra shadows that you don't want. It's used by most of the teams internally that are doing a lot of this stuff. And then we've also got a white paper that our graphics team published. This is just freely available. You can just grab it, and it's best practices. It goes through the whole process, how you use reality capture, all the steps involved. And then there's this YouTube link here is a talk that Matthew Mueller gave on how to use photogrammetry in Unity. So the characters, again, real-world costumes. So we actually have these costumes that are physical props that we went through and did the photogrammetry scan with. And again, they had their own internal inside of Oats. They built their own photo booth so they could do the photo scans and then go in and clean it up and turn it into the meshes afterwards. And then the raw scan, you see it's still kind of noisy, and then the artist cleaned it up. And here's the final model. They also did photogrammetry on all the materials. They had a special material scanner, but human face textures, again, your normal PBR standard workflows, so a lot of substance designer for cleaning up. They did Die4D for the facial capture, which is there in the expo. They're a really cool facial capture. It's kind of just basically frame-based capture. And then they brought it in and sort of grabbed a bunch of expressions, and then essentially they become kind of like morph targets. Clothing design, again, all of the bits and pieces in the costume were all physical props. And then we use Marvelous Designer to supplement them with tarps and cloaks and some of the other goodies. And so the Marvelous stuff was brought in through Alembic. So here's the photo scanner for the materials. So they actually would bring it in and get the actual physical material. So all the light propagation, everything, they would scan the physical props. And then after they brought them in, then we started building it in the engine. The profit was terrifying when we started because we wanted to do crazy, hyper-realistic. Oats they have a pretty high exacting standard. So we had to do a lot of implementation, subsurface. This is available for free out of the box with our new HD render pipeline. So we had to make sure that worked in the older version of Unity. This is actually up on the asset store now. You can download it and try it out yourself as well, this character. But we were able to get some really cool tech there. The eyes as well. Eyes are always tricky. So we built some custom shaders for that, basically doing the pupil manipulation. So the whole thing was basically mocap. So we went to Animatrix in Burnaby and did a couple days of mocap. And then essentially all the clips get dropped into Timeline. And on the bottom, you can basically see that's their shotguns that are their shot tracks. And then they would just mirror for each of the characters. And then they would capture the video reference for eye animation and the body connection. This was critical for this step because the Die4D is the sit-down setup. So the actors would have to do their mocap and then run over and sit down and basically do the lines. But we needed the eye reference for where they're looking and being able to actually connect the eyes because Die4D is kind of the head and the facial movement, but it didn't do the eyes. Rigging, Eric, their rigger, is a wizard. So he Did all kinds of magic as usual for putting the rigs together. Again, mostly they were just FK rigs for loading the mocap data in though. So it's not, we weren't doing much in the way of keyframe data. Cloth simulation, the usual, marvelous. And here's, but the big thing is they captured the reference because we had the physical props. They could actually use the video reference to compare. So they get the actress to walk with the suit and figure out how everything's supposed to work in the real world. And then they would do the same thing in Marvelous and be able to sim it out and kind of rerun the sims and try it out and make sure everything is actually behaving the way it should. And then here's some of the reference mocap shot.
1-1A, felony, treason. Consortium Criminal Code. Article 1-1A, felony, treason. Consortium Criminal Code. Article 1-1A, felony, treason.
So it gives us basically a frame, or basically a mesh per frame that we use to from the Die4D system, and then they would have to stitch it to the head, and then we layer the cloth on top of it.
Consortium Criminal Code.
The head playback in
Article
Engine was all Alembic,
1-1A.
so we'd bring in Alembic clips
Felony.
for the head, and then Alembic for the cloth, and then the body was brought in through a normal skeleton animation. Resim it all in Marvelous, make sure the cloth and everything, all the interpenetration is sorted,
Criminal Code.
and then here's the final result.
Article 1-1A, felony, treason.
So working in real time was, as much as it was a brand new thing for Oats, they took to it like fish. They jumped right in. The learning curve for them was, it's funny for the artists, they were like, well, I just had to export it slightly differently, but they were pleasantly surprised that it was fairly easy to switch to. We did quite a bit of custom work for it. This is basically their pipeline. We start an editorial shotgun, the traditional sort of workflow. Normal asset production, the animation, which is the mocap, your look dev, a lot of the caches for cloth, and then the faces as well, the VFX. Actually limited VFX through Alembic, but most of that was done in Engine, and then basically assembling it all in Unity to the final render. So this is the change from their traditional pipeline to the Unity pipeline. So. It was, most of the production ends up being the same. It just is, you're kind of putting it all together in Unity. So, for Unity scene organization, this was breaking it apart into multiple scenes is critical for working with multiple users. So their team's about 25 people, and they could all be in the project, all be doing their sub-department, their separate disciplines together. So you had lighting, set dressing, the effects, the camera, photography guys, and the animation. And then basically we sort of wrap it all in one system, so you can just open up a specific sub-scene or subset, or the set dressers could, or the environment guys could open up that subsection. And then the main timeline basically plays the whole episode, which compiles all the different scenes together. So the per sequence timelines, again, we broke it out for the main one, and there's lighting, characters, Alembic, crowd, and flares. That's kind of the standard sort of breakdown that we had. So a lighting one would look like this. So photography, you can see, all the yellow ones are actually custom tracks that we wrote. So a lot of it's like switching, turning on and off lights, switching between post effects, doing lens pulling. See shadow cascade, so adjusting where the shadow volumes fall, so you can get super detailed shadows up close, and then have the distant shots work still. F-stop pulling, and then the edit point one, which is their shotgun integration. For the characters, again, most of this is just mocap, so a lot of it is just dropping the clips in as is. Unity's pretty good at adjusting FBX. We have a new partnership with Autodesk that's making it even better. So yeah, you can just, the nice thing is the mocap facility provides the clips, and you just drop them in and they just magically work. It works really well. And then the Alembic caches are actually fairly similar because they had their shot breakdown. They could just re-render or redo the sim for a specific clip, and it would just drop in place. We wrote some custom lens flare tracks for doing all the, I'll say J.J. Abrams lens flares, but the Neill Blomkamp lens flares. He has a lot of like cool anamorphic lenses. The challenge, or the reason we wrote custom ones versus the ones in Unity, when the light goes off screen, they kind of just go away, whereas obviously lenses don't do that kind of thing normally. So he wanted to get a proper cinematic lens flare. And it was basically a full post system. And then the crowd, which is sort of the background clips. And the trick here was we could create a micro timeline that's basically the 3 or 4 characters doing their loop, and then copy paste it around the scene, and suddenly you have hundreds of the traptions in the background. And then you can do slight offsets, kind of shuffle them around, and then they basically are all behaving the same. So this whole line of traptions is essentially the same 3 or 4 that are copy pasted around. So you can see the variation of it. So just kind of shuffling them to kind of get the proper offset. So they aren't walking all identically and stuff. So. And then grouping it all together. So you can move the whole background group together. Being able to isolate and separate your timeline sequences like this is very effective, and it also lets you sort of isolate these things for asset management, for team management. So each of the sub timelines is a separate asset that you can check in through Perforce and sort of manage independently. So people can be tuning the background stuff while the team's working on the foreground piece. So yeah, this was kind of the one touch point they did with Shotgun, is they had this EDL track. So they basically generate an EDL out of Shotgun and load that in, which gives them the reference where all the other clips go. And it also was used for when we're rendering out the shots. So behind the scenes for photography, so yeah, you'd have a single shot. Unity has a pretty cool procedural camera system called Cinemachine, but Neill was the Cinemachine for this project. So he's basically, all the camera work is Neill running around. And then the cool thing was, once he had his footage of the actors, he could go in and reshoot the cameras for it as many times as he wants, because he can have the virtual production sort of heads-up display of the action, and then directing the actors themselves. Some of this stuff is starting to get built into Unity. At the time, we had to write some custom physical camera conversions, making sure that your field of view conversion and lens conversion comes over. And then the things like the f-stop puller and stuff. If you use Cinemachine for a lot of this stuff, you get a lot of it out of the box, because you can just tell Cinemachine to track the target, and it'll automatically do your f-stop pulls. But you can get like the cool lens breathing effects and focus pulling for the different effects. So this is our post-effect stack on the right. So it gives you a full set of effects. This is the version 1. The version 2 one's even the supersized version of it. But it's full ASIS color grading per shot per camera in Unity. So you're seeing final picture essentially in the engine with a very DaVinci Resolve looking color grader, if you're familiar with that tool. It was heavily inspired. Again, I mentioned the lens flares before, so we have some cool hero flares. Again, these are sort of not traditional film or not traditional Unity flares, but it just added a whole new look to the pic. And of course, being able to work in real time, the lighting guys they felt like they were playing is like not really working. But having all of the flares and everything behave the way they should, they had a lot of fun playing around with it. So, for lighting, so Unity has sort of a light window, so you can actually check out all the lights behind the scene and manipulate all the different views. Being able to actually dive in and check out some of this stuff, again, all in real time. We had 3 main sort of lighting scenarios. We were baking GI and manipulating the directionals per lighting scenario. So we had the outdoor nighttime, Indoor nighttime for the second half of the second episode, and then wrote some custom light attenuation stuff to sort of do the light map cookies. And then the light flickering, it was basically sort of adding some procedural noise to it as well. And then the outdoor daytime scene. Again, they're fairly simple scenes. This outdoor daytime scene was actually fairly tricky because originally Neill wanted it to be 12 noon, which if anyone shot a scene at 12 noon, it's tricky to get looking right. So at the very last minute, we finally convinced him to shift the light a little bit, and it made everything look infinitely better. So that was sort of that one. And then you can see the trails from the smoke. That's basically a custom little emitter system they did for the lighting. And then obviously there's sort of the scene lighting, but then the per camera lighting essentially, which was obviously important for per shot based lighting to get the final look. And then masking. Marian's transparent mask was problematic, let's just say. So trying to get that lighting and doing all the translucency for that was fun. Again, lighting cascades, controlling the shadows, being able to actually drive the shadow cascades from timeline is a super simple script, but it adds a whole lot of detail to it. So the mirror herself, she had a whole ton of tech. That's why we focused on it for the real-time live. She basically had this dynamic deformation system in her face. But because it's playing on top of the Die4D Alembic cache, we had to sort of layer a few things onto it. So there was the base mesh in the Alembic cache, which is actually relatively low poly. And then we had Phong tessellation on top of that to give it basically enough geo. And then it's basically an animated normal map on top of that to do the deformation. And then we had a control panel that they could tweak. When Neill kind of came up with the concept for this, we had no idea what he was actually looking for. So we just kind of created some tools and then let them play around and come up with the final look for it. And it's all using the custom render textures. But now in the modern Unity, we have a full node-based shader graph. So you could actually implement the same thing fairly easily using just the shader graph. Again, Marian's mask, the transparency for this was challenging. We called our graphics team. We're like, how do we do this? They said, you don't. And then we're like, okay. So John Parsay, the graphics engineer, he's giving a talk, I think right after lunch. He's the wizard that helped put all this stuff together. Basically doing the proper sorting and getting the light shading. That was one of the more troublesome shots in the whole thing. Being able to do the proper sorting for that. And then the VFX, the fire effects were just gorgeous, but a lot of it is just built-in normal Unity effects. They do a normal flipbook, basically pre-cache it out, a lot of lit particles, some built-in noise, sparks. And then they did write some spline-based particles for just the candles around the cult leader sort of layer, but the fire is actually fairly standard, which is, but it looks really awesome. And then background tarps, again, they simmed a lot of the background ones and just replay them as Alembic in timeline. Just adding some extra detail to the scenes. And the nice thing is it all just syncs together. And they become clips that you can just sort of reuse. I've had a lot of questions about like why wouldn't we use Alembic for even the characters and stuff. And the big challenge is you can't blend the clips because they're just arbitrary sort of point caches. Whereas FBX clips, Unity has a lot of really cool blending tools, so you can take a walk cycle, blend it into a run, and so on. But you can see when he's dragging the clips over, it just overlaps and cuts off the other clip. So that's sort of one main. You could bake down the whole character sim, everything down to Alembic at the end if you wanted to, The other challenge with Alembic is it's a streaming format, which means it's coming off your hard drive. So there's a lot of just data throughput issues that we ran into. So Unity's working on some more optimized native cache streaming to sort of improve that. So what worked, what did not? So the big thing here was they set out a very high bar. They wanted to do photoreal humans. They wanted to do everything that they do normally. They didn't want to have to really change around a whole lot. And most of that actually worked pretty good. They were pleasantly surprised, and we were pleasantly surprised. There was certain key things that we obviously needed to sort of sort out, like the translucency and some of the details and how, like, for example, Marian's mask and so on worked. But the majority of it worked pretty good. Adaptation of the VFX artist to real-time, again, the big change for them was they're outputting to FBX instead of just rendering in Maya. But that was really the biggest change. They had to do lighting in Unity, but again, because it's real time, seeing everything in context, it was, again, there's some good quotes I think on the website where it just felt like they were playing. Is like, I'm not really working, because you normally have to do a thing and then walk away, come back like X hours later and see if that change actually made a difference. But being able to tune things like the flares and so on in real time was really sort of a game changer for them. Some of the flickering in the cloth, we had some depth issues. Yeah, it was the future. So Oats is trying to figure out where they're gonna go with some of this stuff. They feel that it was a really successful project, and they're super interested. Again, Chris Harvey and Neill both were early potential interest of real time. They've been wanting to do this for a long time. So the trick now is sort of what they're going to do next. I know Neil's off shooting RoboCop or something right now, but he's supposed to be back in town soon. So we're going to be chatting a lot more about where we're going with this. That was it for the slides, but so I've actually got the project as well. So I'm going to jump in and sort of just show some of these things in a practical sense. Actually, I've got a simpler project that I can even show as well. Let's show this in as well. This is something that I've been working on in my so many spare time hours. So here's the full project. Again, we broke down things in the different scenes so we can turn on and off the different elements. And when you're putting together a project, when you're working on multiple, when you have a larger team, you'll want to start splitting out things into the different disciplines. So again, the lighting guys could load up the lighting scene with just the set, and they didn't have to worry about loading up all the heavy animation or Alembic caches. And then being able to, I just have to figure out where the characters are. Here they are. So then all of you can see the different tracks here. This is the different timeline sequences, and we just organized them underneath. So you can just jump over to the characters, for example. And here's basically all the mocap camera data. So including even the camera movement, it's just basically a single bone rig, but that's the mocap camera. And then switching the active sort of assets in all the crowds. The Alembic caches. So Alembic, again, it's just basically a format. You load in, you can see all of the different clips, and then we're essentially just playing them in Unity in order when you come through. So this particular scene has sort of the silo, which is kind of the background. Then there's the cloth, and I can't remember which character this is. Some of the gravel. They had a couple things in the background. Let's see, what's another interesting scene to load? Actually, I'll just jump over to this one. So this is a very stripped down version of that same scene. So here we have sort of our master timeline. And again, breaking it down into beats. So this is each one of these is essentially a sub-timeline. So we have our master timeline, which is one asset, and then we have 4 sub-timelines. So in this case, I've only got 3 beats. The 4th one doesn't have any animation in it. But each one of these is its own sort of production flow with its own subset of potentially nested prefabs, so you can split your team to departments. So if I jump into this particular clip, I have the camera. In this one, I'm actually using Cinemachine to drive the camera. So I've got the camera rig, and then under there, I've actually parented a Cinemachine camera. So the Cinemachine camera is handy because it gives you things like if I want to adjust, like you've got the movement so you can get all your handheld, but then you want to adjust framing, you can actually jump in here and actually play around with the framing after the fact. So you don't have to go back to the mocap stage. If you're like, okay, maybe I didn't get enough handheld noise, I can actually add, we've got our own sort of procedural noise on it, and I can actually add my own handheld noise here. So if I go into play mode and check it out, oh my God. Of course. I love that. All right, never mind. Good thing we've got multiple Unity projects open. I love live demos. So one thing with the way that they worked, again, because it was a traditional VFX flow, you can probably see they've got their naming convention, and again, at the very bottom of the master timeline, this is their edit point, so their EDL track. This is actually it's actually more of a dummy track, but it's just basically giving them the reference point. So when they could do shot reviews or look at things, some of them are longer, some are shorter, but they could actually go through and figure, okay, you got to re-render 20 or 30 or 50 or whatever it is, and be able to actually reference them. Lighting, again, we had per beat. So they've got specific per shot lighting. And they're essentially, as you can see it just turning on and off the different clips for the lighting, and you can see the environment changing its lighting scenario. Let's see what else is cool in here. Some of the things they did for set dressing that are interesting. You can see all these boxes in the scene. These are all, it's just basically decals, but so they kind of play down the base one, and then they just threw in hundreds and hundreds of decals to sort of make the thing as dirty as it needed to be. I'm going to be brave and try to hit play on this one too, and see, so you can see all the effects, and I can grab some of them. Okay. Whew. Okay. So here we can see when you're in preview mode, you can jump in and see all the effects live, tune them, kind of play around with them. And sort of see what's going on with them. I'll turn off the decals, and we can jump in and select the effects. More decals. So here's the, all the different effects, the fire and so on. So again, you can just tune all of these properties live in Unity, and then copy and paste the scene once you've kind of got the look and feel that you want. And let's jump into the mirror scene. Interior outposts. So you can see we've got all the multiple scenes set up here. So I'm going to just go back to an empty new scene. So we have a scene loading mechanism, so you can just jump in and just load the one main scene, and it'll load up all the sub scenes all together. This one might take a moment because it's a large scene. It's not bad. But yeah, each of the flares, everything is all sort of broken out into its own little sub-department. And then they have the master timeline that controls everything. And because it's all, again, everything's sort of fairly same structure, you can jump around between shots and between scenes fairly easily. Let's see. This environment, the interior here wasn't, I'll turn off some of the lighting so we can see it. So this one was all done by Virtuous in town. They're a great outsourcing shop, so they created all the environment here. And then again, these traption groups, that's the crowd background pieces. And you can see that we've got just basically the midground, foreground, all the different clips. And then each of them is their own sort of sub clip for the different crowds. So that's that particular guy there. And then he sort of, you just copy and pasting essentially all the different clips around and moving them in. Let's see. The mirror, I'll jump over to her for a sec. Let me hit play and load her up. Let's see, where are we? Where does she come in? Here. So this character, again, was fairly tricky, but we can look at the different pieces of her sort of setup. So she's got her cloth, and then basically the head geo, which is another Alembic cache, and then basically the rest of her body, essentially. Now, this one was particularly challenging because when you're trying to layer all these different pieces together, it was very trying to synchronize them all. I gotta remember what I turned off now. Was it all this? I'll just scrub to a different section. When you're synchronizing all the pieces together, it was we had a lot of interpenetration initially. Because Alembic is just a frame-based output, you're outputting it at, say, 30 frames a second, but the mocap animation is curves. So you're trying to blend essentially a curve animation with a stepped frame animation, and it was so we ended up having a lot of interpenetration and kind of just trying to sync up the layers. So what we added for Alembic was interpolation. So you'll actually blend between the different essentially vertex points for the different frames. That gave us some interesting benefits as well, because you could theoretically output an Alembic cache at 15 frames a second, but play it back at 60, or some of these other sort of advantages. Initially, the Alembic implementation in Unity as well didn't have motion vectors, so we couldn't get motion blur or any of the other goodies with that. So we added motion vectors to it, so you can actually play back the different scenes in time and in sync. Let's see, what else did we add for the... it's always interesting watching the different shots because they only simmed out the cloth for the scenes where she's on camera. So for all the different characters, you can see them disappearing and appearing. Again, when you're working per camera, per shot, that's sort of just what they did. It's kind of different than the approach we took for the Baymax Dreams project, which was kind of trying to be less camera specific and more world space animation. It obviously means you might need to make more animation. That's sort of the downside. So trying to figure out what the balance there is. Let's see. What else do we have? All right, I'm going to be brave and try and open that other project again because it's going to show you a bit more how to put these things together from scratch. Go. Okay, so again, master timeline. Again, this one is driving the other timelines. You can scrub when you're scrubbing, you can see how it's synchronizing even though I'm in a sub-timeline. You can see your local time or in your global time, so you can actually see where this clip is in context for the rest of the clips. And then if we zoom in here, these are all the individual clips here, and we can just go and find the original source assets. And again, they've got it broken down per beat. I've only got 3 of them loaded in here, but these are essentially the raw clips or all the animations for each of these segments. So in this case, I have the 3 characters as well as the camera. And then for the different animations for the characters, I'm just dropping the animation literally onto the track, and it updates. So the character's in the scene, and it moves it around. So that just animates Adam as he does his thing. And in this one, again, because they're working per camera, you can see, I think Adam does a little jump at one point. Yeah, so he does a jump because the camera cuts and he's already there. But again, these are all sort of the default mocap, sort of just how they approach their shots. We also have, so all of the clips when you're actually outputting stuff is all the Unity recorder. So we actually have a frame recorder that'll output, you can actually bake out animation. So if you're actually animating or keyframing in Unity, you can output that. You can output movies. or even like GIFs and stuff. But for most of the final output, we're doing image sequences. And there we have PNG, JPEG, or EXR. The JPEG is actually pretty quick. You can almost output it real time at that rate. PNG, the file encoding is a little slower, but it's super crisp. And then obviously EXR, and when you do EXR, you can also do alpha as well. So for final output for Atom, we did PNG, same thing with Baymax Dreams. We're just outputting 4K and then downsampling to 1080. Gives you some extra anti-aliasing. And then here you can just sort of choose what your output resolution is. And then you have it's just basically a clip that you put on timeline. So if you want to re-record this one sequence, you can output that and then basically assemble or do what you need to outside. Some other goodies that we've put together for timeline is we've kind of written a couple of sort of a library of tools for like alignment and clips. Being able to replace animation clips. And then again, the power of sort of using Cinemachine on top of it is cool because you can kind of combine the benefit of doing a mocap camera as well as some of the targeting stuff that it does. Let's see. What other goodies do we have to show? So one thing that we did with, we're organizing kind of like a film sample to provide to the community. And it provides things like being able to break out the scene loading mechanisms. So again, here I've got the main scene, the timeline scene, which is where all the photography is, as well as your sets. And we've created a simple system for configuring your scenes. So here's the series config. So this is kind of like your master config. It's designed for episodic content specifically. So this is kind of a list of global scenes that any one of your episodes is going to use. And then the episode-specific config. And this is just an arbitrary list of scenes, essentially. You can have 1 or 10 or however many you need to, depending on how you break up your scenes. And then when you open up the scene, I don't know what I broke, so I'll just not load that. You just open up the main scene. It opens up all the sub-scenes as well. Unity, this one is actually set up in the new HD render pipeline as well. And here you can show you some of the goodies that we have for that. So essentially all of the volumetric lighting, you can control all the volumetrics and all the depth contribution and how foggy you want it to be, as well as sort of its global light control, and then the post stack as well. This is something that we've kind of figured out after the Atom project. We did this for the Dream project, but the post stack is actually, it's a stack, so it's actually stackable. And you can see here, you can sort of set up overrides. So you could say like all or none. So you could say maybe I just want to do this one for this specific level, and then have per camera overrides on whatever it is. So for example, you could have color grading on the whole shot, and just play around with your color grading for your whole scene. But then if you need specific overrides for specific camera clips, whether it's depth of field or bloom, then you can actually have specific overrides for those individual clips. And it works really well for doing your final shot lighting where you're trying to really push the final limit there. Yeah, I don't know, I can talk about this stuff all day, but I don't know what. Let's see, maybe I'll just open up for questions because I've got a ton of stuff. I can just jump in and show things. So if there's any specific questions, we can just start there and then figure out what people are interested in. So and we've got a microphone. Don't be shy.
So I have some questions about, I guess, effects stuff.
Sure.
Is it pretty much just all particles within Unity? Did you use any like Houdini or other software to simulate and then bring in?
I think the original flipbook that they created for the Fire, they used Houdini. So you can just create sims in there. Houdini also has a really killer Unity integration. So they've got a version of their simulation engine that you can actually load Houdini assets right into Unity, and it'll play back, so you don't actually have to bake them out already. In 2018.3, we've also got a brand new visual VFX editor that's coming out that's all a node-based VFX editor that allows you to do, and it's all GPU accelerated as well, so it allows you to do some pretty cool effects. So you can kind of combine the two, do sort of part of it in one, supplement it in Unity. Our internal particle system's pretty good, and especially the new one, it's capable of doing some pretty cool stuff. So.
One more question.
Sure.
HDR, is that something?
Yeah, it's all linear HDR out of the box, and even our post effects, all the things that it's doing are still in HDR space. It's just the final blit to screen that is the LDR conversion. So. And in the back.
Hi. Do you know if the Alembic importer has an API for things like custom attributes or just extra data, metadata that you add to the file?
I don't know the answer off the top of my head, but I know that all the C# layer of it is exposed, and if there's specific things that you need or are looking for, you can always get in touch with us, and we can look at exposing them. The whole implementation is actually up on GitHub, so you can look and see. It's essentially the default Alembic sort of implementation, and then we've wrapped it and exposed a number of stuff. For the other project, the Dream project, the Baymax Dreams one, we, for example, we wrote a custom layer on top of it, so we're not using the default UI that Unity gives you. So we were sort of writing our own tools based on the underlying foundation. So I don't know the exact answer, but it's pretty extensible if it isn't. And if it's something that you feel you need, let us know.
Hey, thanks.
That one up over here.
In terms of camera capture, is optical-based virtual camera the only system that's really used for capture, or is there any tools that can get stuff from like a Vive tracker or an iOS device or Android device or something like that?
Yeah, absolutely. If you can get position data out of it, you can get it into Unity. So, like the vast majority of VR stuff you see is in Unity. So we can get that data into the engine. There's also been demos that we've shown at, I think it was Unite Berlin. We showed a facial mocap demo with that, and there's a whole bunch of example projects and things using the whatever 51 morph target sort of system that is available out of the box in ARKit. And we're working on, I can't remember when it's going to come out, but we've got an internal prototype of basically capturing the data with that, being able to just drop it right on timeline, being able to scrub the facial animation. Can't remember what the status of that is, but it's a thing I've seen internally, and we've shown it on stage. I just don't remember when it's coming out. But I know that a couple of our XR devs have created a number of like YouTube videos explaining, and I'm pretty sure GitHub projects that you can just try out on your own. In fact, I'm almost positive there's a GitHub project that they've shown. Jimmy's on our XR team. He's doing a ton of experimentation with that. So.
Okay, awesome. Thank you.
And I know that a lot of the mocap stages, they're actually supplementing with like VR Vive trackers because you get a lot more accuracy actually out of the Vive tracking. You don't get quite as big of a space as like a big mocap room, but for doing just single actor or prop, you can layer that on top as well. So.
Was the lighting in the Atom shorts all using dynamic lights in Unity, or was there some baking of light maps involved in some?
We didn't bake any light maps, we baked GI. So there's basically a GI bake, and then everything else is real time on top of that. So it's, allowed them to kind of play around with the light angles and so on, and I'll load it up and play around with that. But yeah, everything was real time. And I know we've got a new GPU light mapping solution that's coming out and a couple other sort of tools along that regard. So I'll jump into the this set because it's actually pretty cool and shows off some of that stuff. I was remind everyone this whole project's running on my off-the-shelf laptop. Like it's a 1060. You can hear it screaming away, but it does run. It gets kind of hot, but I don't know if you want to work full time on the laptop, but it does technically work. So that's kind of the cool thing is it's not any magic hardware or anything. Where's the master scene for this one? Yeah, so here's some of the photogrammetry assets. You can see it's the final result when you get into them is it's pretty cool. And here's that trash pile they recorded. And then they just copy and paste it around the scene. And any other questions?
I was just wondering, with all the photo modeling, how much time was spent optimizing the models to make them so you can do all of this?
Very little. We didn't build a whole lot of LODs. The photogrammetry stuff is, let me just see if I can see them wireframe. The nice thing about working in photogrammetry is you can just kind of type in what your target poly count is and it'll just generate the mesh and the UVs and everything. So you can see it's not crazy high detail meshes. That trash pile is kind of out of control, but we didn't really optimize much. Again, I think the phrase we use, we're optimizing for quality, not performance. So we did want to have it so you could play back at real time just for iteration speed, but it wasn't really the number one concern. We weren't making a game. We weren't the mirror executable. We did that one project we kind of isolated. We wanted to make sure that one would run at 30 on half decent hardware. Again, we're kind of leaning more on the quality side, like turning all the dials to 11 and not really. Unity's got a lot of really good like automatic down-resing of textures and reducing like the number of active lights and so on that you can do if you're working on something that is going to be real time. But we didn't have to worry and we didn't really worry too much about that kind of thing. Where's the main light in here? Any other questions?
So with depth of field, is there a way to control the shape of the bokeh so that it can emulate the look of an anamorphic lens?
We have a whole physical camera sort of setup that's being worked on that allows you to do lens emulation. But I can't, I wish Adam Myhill was here because he would know the exact answer to that question. But I can't remember. The work that we're doing with Autodesk is a lot of trying to make sure that lenses come across from Maya as is. We can import cameras from Maya. We try to bring across as many lens properties as possible. And then internally in Cinemachine, for example, they have a lot of presets. So you can say, I'm just using a 50 mil, I'm using this, and it'll actually drive the post effects and your field of view and sort of depth of field and all the other things. But as far as like exact like aberration curves and things like that, I'm not 100% sure what the answer is. I know we're doing a lot of work with Autodesk trying to make sure that that pipeline is as smooth as possible so you can do all of your setup and getting the cameras working in Maya and then bringing it in seamlessly and bringing as many properties as possible across. Any other questions? I'll just keep playing then.
Did you guys do anything special for shadows on the close-ups on the faces, or is it just bringing in cascades and focusing your lights in?
Yeah, it's mostly just cascades. We did use screen space shadows, so there's definitely that as a post effect for doing some of it, but a lot of it is just tweaking the shadow cascades per camera shot. So with the super close-ups, you can bring it right in and have the full resolution for that super close-up, and then change it for the distance one. Screen space shadows add a lot for sure. It kind of helps bring a lot of depth. It's just like AO, so you can kind of just fills in the scene essentially. So it's a super handy trick. But yeah, a lot of it is just vanilla out of the box, sort of what's available in Unity. We didn't do a lot of magic stuff to achieve the final look, other than specific materials like the visor and some of the other sort of things. Yeah. So here you can see this drove our lighting guy bonkers, where they were changing the light the global, like the whole sunlight per shot. He's like, "What are you doing to me?" Yeah, so as we scrub through, again, everything was all about working to the camera for this particular scene, or for this particular short. So we couldn't bake light maps, we couldn't do stuff like that, because we needed to be able to adapt the lighting to the scene. Any other final questions? We got a couple of minutes left.
Hi. I'm just thinking about on the production side, like how would a dailies review session run? Are you guys just baking everything out as renders to review, or version up and down? How does that work?
It was kind of a combination. So Chris Harvey's sort of very involved on the floor. So some of it would be just him doing his normal lap around the studio, checking out, reviewing individual assets and things on individual artist machines. And then we would do a sort of a big review with the team. And that was mostly rendering out the clips. So using the recorder system that I showed before, rendering out specific takes. Okay, we're going to review this specific shot, dropping it in, bringing it in. The main reason for that was so you can see it at the full 4K sort of final resolution, and be able to sort of pick out all the micro sort of things that may not, like again, in a smaller view or on the artist machine, they might have a slightly different view. And then for Neill, because Neill was actually out of the office, he's a director, he's all over the place. So a lot of it was remote through just the Shotgun RV tool. So we'd basically get the review in, and then wherever he happened to be, he could do his reviews of specific shots. But it was kind of a combination of, the daily. And that was actually one of the more surprising things for them when Chris would go around and reviewing things, talking about one specific thing, and then realize that this thing in the background that he had just talked to a guy about is already updated because someone had changed it and checked it into Perforce, and it's just there. So being able to actually have all these things just dynamically happen, it was funny because it surprised them in more than a few times when you don't realize how quick things can get updated.
Thanks.
All right, well, if there's no other questions, thank you very much for coming. You can ping me on this is my Twitter handle. And if you're working on cool stuff, the Made with Unity team's always interested in chatting with you. So thank you very much.